Okay.
No worries, figured out how to build a light yesterday.
My YouTube channel. Because it's easier to do that than it is to save and then upload the video. Howdy! You have the workshop?
Yes.
Go ahead and sign in. And we have... Okay, I will give you my instructor robot until we have, until stuff happens, okay? Alright, let's get things started. Only PowerPoint. Okay. Please work. There we go. Slideshow. Alright, let's see if the slideshow is reading properly. It is not. Of course it isn't. There it is. Alright. Oh god, MATLAB. It's bad. It's that line of code is some 600 lines long. Anyway, welcome everyone to the Robot Sumo workshop. For a lot of you guys, I'm pretty sure it's the first time you make a space, but for some of you guys already know, this is going to be a pretty, this is going to be a little bit more interesting of a workshop. We're going to spend a lot more time, we're going to go rush through most of the slides and go straight into this. For those of you guys who are new, make sure to go ahead and go to the Arduino website and download the IDE, so go to arduino.cc and make sure you have the IDE installed. You can start, while you're doing that, so you go to arduino.cc/software and click download for Windows 7 or newer. If you haven't done that already, if you don't already have a copy of it. Hey! Sign-in sheet, take a seat. We're gonna have to share robots. Okay. Yeah. Okay. Alright. So for those of you guys who have not been in Makerspace before, my name is Bernard. I'm the lead Makerspace technician here at the University of Houston. The Makerspace is a part of the University of Houston, whose entire objective is to provide you access to electronics and components and training for free. So our objective is basically, hey, here's we have a bunch of Arduino kits, we have a bunch of Raspberry Pi kits, we have a bunch of Beagle Bones that no one's ever used, we have TI kits, we have Inspire kits. Whatever you guys need for your class or for your workshop or just to learn, you can come here and check it out like a book for 2 weeks, or if it's for a specific class, you can check it out for a month. So that way you guys don't have to spend money, digging through stuff, building projects, or buying something you don't know is going to work. You can talk with us. We also have consultations, so if you ever wanted to just get some advice on, hey, how does this code work, or hey, how do I get started in this project, we're the kind of person you should talk to. So our office is over there, and this is the general space to actually do workshops in. If anyone needs power, by the way, there's a power strip. It should be long enough. Alright, good luck, James. If you can't reach the power strip, you can just tug it back. It's got a little bit of length. Alright. Today's workshop is going to be over Robot Sumo, but as sort of an introduction to how robot software works, and sort of just here's the kicking ball of how to get started on that. So we're going to go first into the general types of robotic software, then we're going to talk about what a system overview diagram is. For those of you guys who attended the last robot workshop, you'll know exactly what that is, but it's going to be a little bit more detail here. Then we're going to go over the robot we're going to be using, which is Sumo 32U4. Because last week was a building workshop and that went terribly, we decided to be a little bit smarter and use pre-built robots for this competition. These are the pre-built robots. Each student, because we have a little bit more students than we have robots, because we only have 5, I'm going to divide and conquer, so someone will be sharing a robot with someone else. Okay? Then we're going to go into the actual, what is Robot Sumo, what are the rules. Then we're going to spend about 30 minutes doing a code workshop, and then the rest of that is going to be us doing fighting, which will be fun. Right? And we'll do a tournament arc if we feel like it. Unlike all of your other instructors, all of your other courses, this is a workshop, not a lecture, not a class. So please, if anything doesn't make sense to you, if something doesn't jive right, if your code doesn't work, don't raise your hand or just shout my name, or just let me know, and I will be able to help you out in the middle of the workshop. So feel free to interrupt me, feel free to shout me down if I'm going too fast or too slow. That's fine. Any questions, guys? Alright, there is one more thing that we need to discuss before we get started. Oh my god, except for there we go. Alright. So, this workshop is being supported by a new student organization that's coming out this year. It is a merger between IEEE, the Institute of Electrical Electronics Engineers, and University Drone Pilots, which is a student org I used to run. They're going to be combining a bunch of different student organizations and the robotics teams into one big robotics team. So that way one robotics team to rule them all, basically. The Discord link to sign up for that is right here, if you're interested in joining that. It is no requirement to join, because it's mostly going to be for training, so it's going to be, hey, here's some workshops, hey, here's some build workshops, hey, here's some other things. There will be sort of a competition at the end, but we're working on that for later. Okay? Any questions, guys? Awesome, let's go ahead and get started. Okay, so for the really dumbed down explanation, because otherwise it wouldn't make sense, software is a series of instructions that tell a computer how to do work. That is directly copied from Wikipedia, who copied it directly from the MIT 1995 textbook on software. There are two types of software. There's something called application software, and then there's called the operating system, both of which we'll be dealing with today. However, in a system, there's usually 4 complete sections of what makes up a computer and how it does its job. So for this robot, we'll start at the very base level, which is the hardware, which is the actual, like, here are the little circuit boards, here are the chips on top of it. For this one, we're using, there's the main computer chip is right here. That's the tiny little chip that does the job. And that is the hardware side. The hardware speaks only in ones and zeros, and it's very annoying to learn about, unless you're an electrical engineering major, in which case you will learn about assembly, which is right here. So good luck there. The next level up is called the operating system, and the operating system defines what the robot should be doing and how the hardware should act. So if this pin needs to move up or down, like to output a voltage or go don't output a voltage, that's all controlled by the operating system. Our operating system that we're using is the Arduino operating system, which is based off the Arduino IDE, which we'll go into a little bit during our coding workshop. Then comes the application software. And the application software is all of the little code and code libraries that are written to make it easier to interface with all of this. Because if you just started writing operating system code or hardware code, coding this would take 6 months. Or actually, no, it takes 3 months, because this is an actual class you can take. When you go to embedded, RTOS teaches you how to start from here. So that is Advanced Micro P, or is that Advanced Embedded Micro P? Is a course you could take if you're an electrical engineering student. That's where you learn that stuff. But this is a 2-hour workshop, we don't have time to go into that. So application software is where most of that stuff does, and then there is the user-created software, which operates at the very top level, that you actually write, you put the stuff into, and it does its job. Okay. There are also levels of programming, and this kind of goes back into our parts of a system. The application software, the parts of the system can be divided into 2 different types of code, and this actually changes the language of the code and how it's written. So there are 2 types. There's high-level programming, and then there is low-level programming. Low-level programming is for the operating system and below. So that is usually coded in assembler, which is a class. Again, that's a very messy. Assembler is almost as close to ones and zeros you can possibly get, besides literally coding ones and zeros. Are you in the class right now? Oh god. So you're in a class just as bad. So that is what low-level programming is. It's usually in a low-level function, but I've also, in the 2010s, it started becoming available in C++ to do operating system stuff. But that is what we call low-level programming. Low-level programming is close to the hardware. It's as close to the hardware as you can possibly get, because you are literally writing your code on your hardware. High-level programming takes a step back from that and starts from the other direction. So high-level programming starts from English. You know, if the robot is doing this, then do this, which is the kind of basic stuff that we learned from coding or from math class, right? Application software usually comes in there's a bunch of different languages now. There's Node.js, there's Python, there's C++, which is my favorite language, and then there's other weirder languages. But this is designed from the math side. So high-level programming is really good if you're trying to do some math-intensive operations, if you're trying to do some graphing operations, if you're trying to gather data, or if you're trying to do all the new stuff like artificial intelligence only runs on high-level programming. Because because it would be impossible to write an artificial intelligence on just a bare-bone chip. It would take any human too long to start writing that. So this is mostly what we're dealing with today. But we're going to be implementing stuff from the operating system of the Sumo and a bunch of other stuff, and we'll go through all of that in our workshop. Any questions so far? Cool. So, for those of you guys, hang on, how many guys are engineers? 1, 2, 3, 4, 5, 6. Okay, so you guys all know this shit. I shouldn't use bad language in my presentation. So, modern programming is broken down into, depending on what engineering concentration you are, modern programming is broken down into into something called library integration software, or there's another term for it that's actually used in class, but I cannot remember the name of it right now. What happens is that these are these little things called libraries, and libraries are little like pieces of code that are being shared on the internet, usually through GitHub or through Stack Overflow, that handle specific operations. Right? They're embedded in each in a class with all of the information inside of it, and does its job. Go for it. This is exactly object. That's the official term. It's object-oriented programming. So so when you're doing object-oriented programming, you take other people's objects that they post up on the internet for you, and they're usually called libraries, and you just steal them and plug them into your system. And this is actually acceptable, because whenever you post your code, most programmers, the more times the code is copied and used by someone, the more like prestige they get on GitHub. So that is how modern operating systems, like how modern code works. The Arduino uses libraries to interface with specific modules. So on each Arduino, if you remember from the workshops, if you have a module that is a piece of hardware that you can attach to the Arduino, you get a specific library to interface that module with that system, unless you want to hand code it yourself. Make sense, guys? This is the how it sort of works for .org files. If anyone here has played OGG files, if anyone here has played Minecraft and knows the audio music for that, this is how it works. And that was the only tutorial I could find online, right? So, because everyone puts their code online, there's been a bunch of organizations who's dedicated to making something called open source. Open source can be broken down as simply is that it's easier to find someone else's wheel online than it is for you to actually just write your own wheel. So a lot of the stuff, especially on the low-level hardwaring stuff, it is going to take you a long time to begin to interface this. It won't take you that much time, but it'll take you time to interface with all of the systems, figure out which pins are the motors, figure out which pins do this, this, and this. Thankfully, everything is posted for you now. So under most circumstances, you should take the time to go through GitHub and see if someone's made something before you have to reinvent the wheel, right? Libraries are usually found on GitHub as libraries or as an API, so that it might be built into your operating system. And this is the modern backbone of software development. Literally, if you talk to any programmer working for Google or for Facebook or for whatever the poor sods are working for, Facebook and Meta are the same people now. Whoever's working, the poor people working for Meta, you can find it. This is their entire job, is going on Stack Overflow and finding a solution. All right. Okay. Let's not talk about hardware, because we have to talk a little bit about hardware in order for the whole system to make sense. I am kind of speeding through this because I want to give you guys more time to code. So, there are two types of hardware diagrams from the last semester. There's a wiring diagram and a block diagram. Wiring diagram actually tells you where all the wires are physically connected. So if you didn't know, if you had just an Arduino and you didn't know what everything's plugged into, a wiring diagram will tell you all of that. The only problem is that a wiring diagram gets really messy really quickly, as shown by this. Which is why normally we use something called a block diagram when it comes to the software side. A block diagram takes all of your components and breaks it up into blocks, and then just talks about and tells you what interfaces you need to do with each, right? So this is the block diagram of this. You'll see that it has the motor driver, which is receiving signals from the Arduino. It outputs those motors information out to the left motor and the right motor, gets power from your power supply, and there's a sensors plugged into the Arduino here. Right? So that gives you a general overview of where you should begin coding your software. If you were, we'll get into this a little bit more often, but each single piece of software here is usually be divided into their own little classes. So there is a library to interface with the ultrasonic sensor. There's a library to interface with the L293 motor driver. The power supply you don't really have to worry about because it doesn't go on your computer board, but for your servo motor, there's also a library to deal with that. So this is a lot more useful when we're going on the software side, because you can just start picking and saying, okay, I need the library for this, this, and this, because that interfaces with the Arduino. Right? Sorry, you want to come watch the workshop? So you know what I'm doing. You know what I'm teaching then. Right, so this is a general overview of what a robot's control system looks like, as shown by the previous one. Typically, there is an onboard computer, so there's going to be some little chip on the bottom side that is handling most of your computation. It does all of the level logic and all of that stuff, so it runs the operating system and runs your code, and then hopefully does the thing you want it to do. It then outputs to a motor controller of some kind. There are a bunch of them, but I'll go into more detail on that in a second, which controls at least 2 motors. Usually, there's some that control 1, there's some control 3, but for typical operations, it will a motor controller will output to 2. Then you have a power supply, which can either be an actual physical power supply or a battery. Battery will power your onboard computer, motor controller, and then you have sensors and human input. So your sensors are systems that you use to try and get readings on what the world is, because it's very hard to put together a level logic without having a general understanding of where your robot is, what the robot is trying to do, and like where the other information is. We're not going to have time to go into that too much today because I started trying to I ran a prototype workshop yesterday, and it was run without engineers. It was run with a I think it was with a political science major. So that went way over time. So we're gonna go take a little bit of time off of that. Okay. All right. There was supposed to be a slide here. Okay, let's just pretend that there's a slide here, and this is not reading Sumo 32U4. Okay. Is trying to figure out what is it trying to do. What is my marker? Here it is. Right? Robot execution commands sort of comes in four process chain. Right? This was covered in the last workshop, so correct me if I make any mistakes here. So the first thing you do is you get something called state estimation. Okay? In state estimation, this is where your question of where am I? Right? That is what your robot is asking is, where am I? Am I on a field? Am I in grass? Am I in some kind of thing? Am I on the table? Am I off the table? What is going on? Right? Then it tries to finds best solution. There's a point for this. It tries to find the best possible solution. So it's solution searching. Right? So it looks at the data that it has from what the world looks like and says, okay, what is the best choice I have to make? Right? Then it executes the solution. Okay? And then then it tries to, it does its thing, it moves its direction, and then it verifies that it's moved correctly. Right? Verification. Once it verifies that, okay, I've moved correctly, it can then go back and say, alright, I know that if I moved correctly, I know where in the world I am. And hopefully this chain continues. Right? If your verification says I'm not where I'm supposed to be, this chain breaks, and hopefully your robot knows to stop. If your execution command doesn't hit, or there's no possible solution, it can break here or here. But this is the general overview of how your robot should be operating. For our specific code, I'll go into a little bit more. State estimation is really easy because our robot's doesn't have to worry about if it's going to be deployed in freezing cold or on Mars. Our robot's going to be deployed in a super field less than about 77 meters away. So state estimation is going to be not too bad. Solution searching is going to be, well, what kind of solution are we going to come up with to fight the other robot? Execution solution is, okay, 3, 2, 1, go. All the robots fight each other. Verification is, okay, who wins, and what kind of data we collect from our winning. Hopefully that cycle will work. Sort of make sense? Okay. That probably didn't go on the audio too well. Alright, Sumo 32U4 is a robot manufactured by Pololu. Pololu Robotics has been a staple of Maker Robotics, or for hobbyist robotics, since the very early days. I believe they were built in the 90s, but they have been around for literally forever. Like, when I started learning programming as an elementary school student, these are the robots these are the company that we looked up to. So, this is Sumo 32U4. It is a robot that comes with a wide variety of sensors. The interesting thing is that it comes with 2 tank treads, which are pretty obvious. Hang on, I've got 4 of them. I'll just show them to you. Pass it around. Pass it around. Open and pass it around. Yeah, so you can open it up in open box and take up a look. Right? It's got a front bumper, so that way you can crash on it. So that way, if it bumps into something on the front, it'll be fine. It only has 2 motors, one on here, one on here, which makes it a very interesting case study. Is it taped? It's actually not a ballad song. Oh, it's an even weirder ballad song.
Oh, I'm sad.
Yeah. Go ahead and open it up.
I thought it was no problem.
Oh, just...
There's also one on the other side. There's also one on the other side? Yeah.
So, the robot has two motors. It has a left motor and right motor. And then it has a bunch of nice sensors for it, for you to do your operations. It has first a front-facing sensor that is just a distance sensor, so it'll measure how close something is in front of it. It has two side-facing sensors that measure side distance, one here and one here. That's all on this board. And then these little black dots on here are for line following. So it basically is a one-color, one-pixel camera facing the ground. So that way you'll be able to tell, hey, is this side what color and this side what color, right? And it'll give you a value between black and white and gray. So that is what is interesting. What's really interesting about these robots is some of the structure of it. Because there are only two motors, it is not four-wheel drive. So can I borrow your robot, please? If two robots are facing each other like this, the motors are right here, so your force is going to be roughly equivalent. So whatever's going to happen is going to be dependent on battery. However, these robots can be pushed up real easily from the back. Because there is no tension here, these robots can be lifted up really easily. They were designed this way because it would be easier to train people, hey, don't just ram into your opponent, that's a bad strategy. Take a step back and think about how to outflank your opponent or get him from the rear. Thank you. Let me now pass it around. Alright. And the really important thing with the Zuma 32U4 is that it's compatible with the Arduino IDE. So it's compatible with the Arduino and its operating system because it's running an 18 mega chip. So we're happy it runs C++ and we're happy from now. Alright. For electrical engineers, this is the wiring diagram for how to actually build your own, if any of you guys want to try doing that in the future. This is only page 1. There are 5 pages of this whole thing, which I can pull up on my Chrome. There are 5 pages of this whole mess, explaining, hey, where does everything go, what systems that it has. So, you know, see here the motor controllers, resistors, color sensors, right? There's even diagrams to explain, hey, here's how to actually assemble your code. Nice. Including what systems it has on it to sort of get you some sort of data, right? But for the moment, I'm just noticing now that the slide's a little bit to the left. Okay. Alright. But because this is very hard to understand, we should break it down into block diagrams. So I've gone ahead and done that for you. You can do that by just going online and seeing the specs and manually mapping out, okay, well, how many blocks there are. But here is a block diagram for the Zuma 32U4. So, there's an onboard computer, which is the A-Star 32U4, which is a version of the 18 mega 32U4. This is an Arduino compatible chip, which is really nice. But the benefit of that is it actually got a little more power than the Arduino, so that way you can run all these nice sensors, right? It then connects to a motor controller, which that is the motor controller type you're looking up, which controls your motor left and your motor right. However, it does a little bit more than that. In each motor left and motor right, there's a thing called an encoder. An encoder tells you how much the motor is actually rotating. Because motors only take an input voltage of only have a measurement of input voltage of like, hey, I'm adding you this much power. Most of the time, you really don't know how far a robot's traveled. Same thing with cars. If you imagine on your car, if the only thing you knew was your engine RPM, you didn't know what your speed was, it'd be very hard to tell what the speed of your car actually is without looking out the window. So an encoder is a little chip that they put inside of it that gets you inside of your motor that gets you the speed data. That speed data goes back to your computer, so that way it has some data there. It then has a couple of other sensors. There is the line following sensor, which is the bottom three color sensors here. There is the IR proximity sensor, which are the crash protection sensors here, and facing the front. Little tiny things. And then it has a gyrometer, accelerometer, and compass. So it has the same accelerometer and compass as in your cell phone, which is quite useful to have, which can tell that, hey, if I'm being pushed at, if I'm being flipped, if I'm being turned around, it'll be able to actually figure that out by itself. If any of you guys want to try taking an interface with that, there's example code that we're going to dig into a little bit, but we're not going to have time to go into that much detail. Then there are also 3 buttons. On the robot, there are 3 buttons right here, here, and here. There's also a button for reset. These buttons are for human input. So that way, if you want to say, hey, run program A, run program B, run program C, that is what goes on there. Okay, any questions so far? Alright, let's talk about the history of Robot Sumo. So I've been watching Robot Sumo since Robot Sumo as early as 2009, but it has since died a horrible, horrible death because of coronavirus mostly. So we'll blame that on the Chinese as well. I can say that I'm Chinese, okay? Alright. It was developed in Japan around the early 1990s. At that time, it was literally just wire a modem to a battery and pray that it hit the target. But it has then become, in the early 2000s, so I believe it's 2007? I want to say 2008. The Japanese Ministry of Education approved it for nationwide tournament. So it's now a national thing in Japan. We are going to be using our version of sumo wrestling, which is copied off of Japanese sumo wrestling. The history of sumo wrestling is that it was based off of real sumo wrestling. So if anyone or is obsessed with Japan culture, will have seen sumo wrestling. Sumo wrestling, there are two people who are usually pretty heavyweight. Their objective is to push each other out of the ring, and whoever gets out of the ring first loses. Right? It hit its peak in 2018 with multiple national tournaments. So there was a Europe-wide Robot Sumo League. There was a Asia-wide, which is controlled by Japan. Then there was a China one, because China and Japan don't like each other. Then there was a North America one, which unfortunately never made it as far out as here, because BattleBot's a lot more popular in the United States than it is in Japan. And there was also a Brazilian one, which I don't know how it got sent to Brazil, but you are going to Brazil, just happen to do it. The Premier League is still kind of being held in Narashino, Japan. It is I think it's near Kyoto. I'm not good with Japan. But this is considered the Premier League, where all heavyweight robots do their fighting in. Let's pull some videos to show you the whole thing.
What's the audio? Oh god. Fuck. Okay.
お前はもう死んでいる。
So that video sort of made the rounds on the internet. Robot Sumo, sumo wrestling has been a very popular thing in Japan. It's, god, now that got 7 million views. In the Japan ring, the ring is 100 centimeters. And they also get to custom build their robots as long as they meet certain size requirements. So it has to fit within 5 centimeter block. No, it's actually bigger. This is a 20 by 20 centimeter block. And it has to weigh under, I think, 3 pounds. However, that means that they can build them to go really, really, really fast and make really, really crazy moves. So you can see, yeah, you can see why we decided to get these little robots which go a lot slower than this thing, because this is a very crazy competition. What's really interesting about what happened there, you see that, so some of these robots have interesting tactics. You see this? That is something called an IR shield. And what it does is it confuses the other robot by having big little like flaps in front of it. So that way the robot tries to hit the flap so that it's hitting the robot. Oh, that is bad. Oh, come on, exit, exit, exit. Oh. Hey, okay. So, this competition has been very popular in the last couple of years. It has, again, begun dying a mildly slow death. But these competitions they're planned to be restarted in 2022, and whenever those live streams come up, that'll be an interesting thing to watch. Alright, back to actually doing the PowerPoint slides. Okay. So, we're going to be using a modified version of the game because that's designed specifically for the Sumo 32 robots. Mostly just because the actual competition is really expensive. Like each of those robots costs about $200, and a field costs another $200, and setting that all up takes forever. Again, these are like all those people that there are entire universities competing against each other just doing sumo wrestling. So, you know, if any of us wants to build a team to beat A&M's butt, let me know. But we're going to be using Sumo 32 force. In this world, it's going to be very simple. Who's got a robot? Pass me a robot. Yeah. In this competition, there's going to be 2 robots in a ring, right? So, this ring in the middle, they're going to start on this gray line as close to them as possible. You can choose to be a little bit more forward, a little bit more backward. but as long as you're kind of on the gray, the shield's kind of on the gray line, you're good, right? Then each robot will try and push each other out of the ring. So whichever robot comes out first, hang on. Okay, so let's see if my instructor code is working. Yeah. So on each robot, there are going to be 3 buttons, and each of these 3 buttons is going to have three little different code options. So each one of those 3 ones operates a different strategy, which that's our solutions, right? Lost my train of thought there. Okay, that is the basic gist of the rule. Whoever comes out of it, whoever gets kicked out of the board first loses. So whoever stays in the ring wins. The if both robots are stuck for 5 seconds, so if they start pushing each other and then nothing happens for 5 seconds, we call a tie and we reset the board. So that way we don't overrun the motors or we don't drain your batteries. Make sense? Okay. Thank you. You can. Sorry. All right. So let's talk about some basic strategies there. We saw one of them, which is a pretty easy one. But there are 3 basic strategies to come up with. And this is, if we look back at this chart, this goes into solutions. So these are the 3 easiest solutions that we can come up with for these robots. There are a bunch of others. And if you can come up with your own strategy, go for it. But here are the basic ones. The most basic, simple option for, hey, how do I do robot sumo wrestling, is to just ram the opponent, right? Just dive straight into it, push them out of the ring, and hope that you have more motor power than them to get out of that. The good news is that it's very, very simple. So as long as you hit your opponent, as long as you have a little bit of luck with you, you'll be able to get them out of the ring. The bad news is that the winner is usually random. So if they also decide to push straight at you, then you're just going to be stuck there for 5 seconds. Or, even worse, you're going to run out of battery before they do, and they're going to win. So it's a pretty big gamble to make this decision, right? Dodging is the usual option. If you know, and you shouldn't know, but we all know each other, so we probably all going to know the same code. If you know what the other robot's going to do, you have a general idea of what it's going to do. Like if you know the other robot's going to ram straight at you, you can dodge to get out of the way in time. So that is option B that I've programmed here. As you can see, it gets out of the way, so that way if the robot's pushing at us, it'll just be, the other robot pushes stuff out of the way, it'll be funny. Right? That is a pretty good option if you know what your opponent's decision-making platform is going to be. But if you dodge wrong, or if the opponent knows how you're going to dodge, you're just going to get hit and get pushed out of the ring anyway. So that is a big oof. Finally, the last possible strategy is pattern. And we saw some of the teams trying to do a pattern search. In a pattern search, you take the board and you divide it into as many different points as possible, or whatever shape you want. So you can draw a square, you can draw a triangle, usually triangles they draw, or you can just draw a circle. And have the robot follow that path, so that way, as long as it and eventually it'll hit the opponent's robot and it'll push the opponent's robot out of the ring. Right? Because you do not have the ability to send the robot commands while it's operating, there's no like, hey, the robot can't really do a lot of good sensing as to where the target is. You can try, and if we have time, you can try to program it so that way whenever it's facing the robot enemy target, it'll ram straight into that. But it's easier just to say, okay, let's have it follow a zigzag pattern around it, and eventually you'll push the robot and push it out. Make sense? And we're going to try and code each individual strategy. That's just part of the workshop, which we're going to start now. Okay, so everyone, I need you to go ahead and crack out your Arduino IDEs. Well, I see if I've accidentally broken my microphone. I have not broken my microphone. Interesting. All right. Okay. So, first thing we're going to do is we're going to go to GitHub. Okay. Hang on. We're going to go to GitHub. GitHub is a website. Hang on. Most of you guys are CS or CE. You guys know what GitHub is. But for break reference, GitHub is where most people post their code so that people can go ahead and use it. This is the code base for today's workshop is going to be right here. So type this into your web browser. And it should be public, and it should look like this. So it's right here. Can you see it? Do you want me to wiggle a little bit left here? Okay. Let me know when we also get to this website. Oh, hold on. Save power. Oh. Some of these batteries are dead. Ooh. Okay. Did it not show up? There we go. All right. Who hasn't gone to this website yet? We're all there? Okay, awesome. All right. So inside Robot Sumo, there's going to be two sections. There's called the demo section and the workshop section. Demo is going to be right here, so we're going to start from there. Inside demo, there's going to be a section called workshop. In workshop, there's a section called workshop.ino and workshop and robotsumo.h. Right? Let's see if I know how to download shit because it's been a while. Okay. There are two options. You can simply just anyone here actually know Git and know how to download stuff? Because it's been a while. I don't use the web page very often. Okay, easy way. Let's go ahead and open up a new file. Okay. Let's also make sure everyone is within reach of a robot. So here's a robot, and there's a robot for you guys two to share. And I'll get back to you guys in a second. All right. The first thing we're going to do is we're going to go to copy paste our code. So we're going to go to sumoworkshop.ino and read all of the code, select, copy, and then paste. Okay. We're then going to press save and save this as Robot Sumo or whatever name you want to name it. Okay. Okay. As you can see, I've been nice, so it tells you some of the basics. So, how do you use press button A, B, and C? And the two commands I'm going to be using are moto set speed and delay and fight start. So these are the four commands we're using. So it'll be moto set speed, delay, moto set speed, and fight start. And those are the four commands we'll be playing around with today. Okay. So the other thing we need to do is we need to go ahead and create a new tab. And that tab should be where we put the other stuff. So it should be called robot. The tab has to be named robotsumo.h. Okay. Then we go back to GitHub. We click robotsumo.h and we copy paste everything there. Okay. Does it make sense?
Create a new tab again?
So go to arrow down here, click new tab. Yep. And it has to be named robotsumo.h. If not, just make sure it has something named .h, otherwise it wouldn't work. Okay, let me know when we're sort of all there. Okay, we good?
Alright, how'd you get to that code again?
So go back to GitHub, click robotsumo.h.
Oh, the other one.
Yeah, and then copy paste that into the tab. Okay. All right. While he's doing that, the final thing we need to do is we need to import the Sumo library. So what I've just done is I've built this is a very general library for how to do sumo wrestling. And the only reason why I have to make you guys go through GitHub and copy paste it is because I couldn't get it approved on the Arduino website in time. Sorry, guys. If you want to because this robot is pretty approved and there are a bunch of them out there in the world, the Arduino has little sections, has built into the compiler ways to import all the data and all of the code libraries for each robot. We're going to go to Sketch, Include Library and Manage Libraries, and a tab should pop up. Come on, there it is. Once we do that, we're going to go ahead and type in the name of the robot. So we'll just zoom into it to U4. It'll take a while because there are a bunch of libraries. As you can see, those of you guys who have not been here, there are libraries for literally every single type of sensor and every single type of unit, including some that are very fun. Very recently, I saw a library whose entire thing is taking Arduino with Wi-Fi and going through and destroying other people's Wi-Fi for fun. What it does is it sends oh god, what's the so because WPA2 has a glitch in it, where if you send repeated commands to it, if you spam commands to it, it won't. No one else connect commands to it. No one else will connect to the system. That's all it does. So it just keeps spamming your wireless router with a bunch of requests to connect, and then doesn't connect. So your wireless router gets confused and shuts down your Wi-Fi. That is actually a library you can download in the Arduino. It's out here somewhere. I can't remember the name of it. But for this workshop, we're going to be downloading Sumo 32. Once you press enter, it should start searching. It'll take a while because there's a lot of them. There it is. And let's make sure we have the latest version. Oh god, I've got an old version. I feel stupid. Okay. Go ahead and click install. Please, please let there not be a glitch between 1.4 and 2 that's caused this thing to crash.
Did we install all the dependencies?
Yes, install dependencies. Let me just check to see if everything works. Please don't crash. Please. Okay, we're good. Okay, it's just compiling. Alright. Come on. Please. Alright. Yep, alright. So there's no glitches, thank God. Alright. So, for those of you guys who actually, since most of our guys are engineers here, we can go through this a little bit. Inside the Sumo 34, so inside the Sumo 32 U4, there are a bunch of little interfaces. Each of these interfaces interface with a specific sensor that you have on your system. So this is where we define the sensor that we're using today, right? So you can see we're using the LCD use LCD to display out, using the buzzer that's called up here. Then we're getting the sensor data for buttons A, B, and C. That's what these three call. That's just to set up that these buttons exist and that they're plugged in. Then we plug in our motors and plug in our encoders. So that's what those two do, right? This is part of the required library to make it make noises. So unless you wanted to program it to play Megalovania, that's not something you can do that later in your own spare time. And then inside of this class, there are two classes. There is Robot Start and Fight Start. Robot Start sets up the robot at the very beginning to first make sure that everything is working. Second, make sure the robot's not moving. Third, make sure your battery doesn't explode, isn't too low. And then 4, it just puts text on the wall, just says robot ready. Then Fight Start actually does a countdown, so the entire code is just 3, 2, 1, and go. That's what's making the beeping noises. So these are the two these are the two little functions that we'll call at the beginning of each fight before we get started. In the Arduino, hang on, everyone here you guys have all done Arduino before, right? Because you were in the workshop.
This is my first time.
Why do I remember you being in a workshop?
I don't know.
Because I'm stupid. Okay, sorry. For all y'all three, the Arduino is broken up into, gives you, when it's a new sketch, it gives you 2 sections. It gives you a void setup and void loop. Void setup is code that runs at the very beginning when you power on your Arduino for the first power on your Arduino, right? Because sometimes you just refresh and get things set up, void setup does all of that for you, right? So that runs once at the beginning. Then void loop runs infinitely as long as it has power. So what's going to happen here is we're going to have, what happens here is robot start, which shows up all the way here, literally just starts the robot, does all the stuff for you, and does stuff behind the scenes, right? Then in void loop, we are going to begin our fighting code, right? So all of your fight code will start inside of here with fight start, so 3, 2, 1, and then go. And then all of your actual motor commands will go somewhere here, right? The if statement, this command, which is get single debounce press, is the command code built into the Polu library for how to test if you just tap the button. Because there's tap and then there's hold. This means that if we tap start, it'll only start the fighting. Otherwise, what will happen immediately is robot will start and then it'll immediately want to start fighting without you giving it a human input. So this sets up to button A. How will we do this if you want to set up button B? Yep. So, else if, make a guess.
So it would be just button B.
Yep.
Dot get single the
Yep.
bounce press.
Yep. And then brackets, and then because we want to have the countdown, so that way you don't unfairly beat the guys, and that way it sort of knows that the rules are fair, we will call fight start, which will give you the countdown so that both teams know that when you push a button it's working, and then your code goes here. That way, when we both push the buttons to start, we don't rip our fingers apart by accident. Okay? So that's pretty easy to go through. Oh, wait, hang on. There's one more thing that I should probably mention for those of you guys who are new to the Arduino. If you guys want to get example codes, if you go to File, Examples, Sumo32U4, right here it gives you tutorials for how to do every interface with all the sensors built on the system. So you can go through their GitHub or go through their webpage. Their webpage is pretty bad with the documentation on the code side, and try and figure out how each system works. Or you can go on here, grab the exact thing you want it to do, and then it'll do its particular work. Sumo collision detect Sumo proximity sensors are kind of codes you guys can look into later today. So if you guys want to look into, since a lot of you guys seem to have a lot of experience with code, you can look into that today to try and put that software up and just copy paste into your network. Make sense? However, just to show you guys, they write an unbelievable amount of code into the system. Like, this is almost a ridiculous level of how does this code work into their system. So if you want to try and decrypt it for the fight today, go for it. Let's go ahead and, just to be sure that we're not missing anything, go to File, Examples, Sumo32U4, and let's go to Demo. Demo for I think this is the LCD version. Yes, LCD version. Okay. Yep, this is it. So go to File, Examples, Sumo34U4, and then it should be Demo for LCD version. Okay. While you're doing that, everyone please check, open up your robots to see if there's got a battery in it. Some of them do not have batteries in it yet. Oh, hang on. So, open up the back, and here are the batteries. You don't have batteries? Okay, neither do you. And do you guys have batteries? You don't have batteries?
No.
Okay, cool.
Who's sharing what?
Good question. We'll figure that out in a second.
He has one, they have one, we have one, and you have one.
Okay.
Okay. 1, 2, 3, 4 batteries to you. These are still charging, so I'm going to be nice and just plug it in. 1, 2, 3, 4 batteries for you. You, right? You guys have batteries.
Yeah.
Got it. Nice. Thank you. And then 1, 2, 3, 4 batteries for you. Please put them in the right direction. So it's pause, neg, and then you're good. Okay, let me know when we all have the batteries plugged in and everything ready. I really need more sleep. I should have started with that first. Anyway. So, for those of you guys who have... Oh, right, when you install the board. Crap. So, before we can actually upload code to it, because this is its own robot and has its own board type, the board's not going to be built in. So when we plug it in the computer, it will detect that there is something plugged into it, but won't know what it is. In order to fix that, we need to actually integrate that board into the Arduino programmer. So same thing again. We go to Sumo 32. Oh right, it's A star. Really? God, what is it? What is it called? Tools. Polu A star. So we type in Polulu. Yep, and they'll come up with this, which is A star boards. And of course, I'm on an older version. We're going to click update here.
So that's
Oh, I see it as well. Do we have to just install like something with the consoles?
It
Like
shouldn't.
the additional board manager's URL? That weird JSON file?
So, no. So that shouldn't be it. Okay, try typing in A star. Okay. Let's try it your way. So let's go to the Polu website. This is the version we have. Sorry, this is the OLED version. We need the regular version. Zumo 32 robot. Okay. Ah, wrong one. Sumo robot. For a USB cable. Alright. Come on, where is it? OLED, Sumo 32 main board. Of course, it's not. Why'd they fucking put it?
It is. I just looked it up.
You looked it up?
Additional board manager's URL.
Okay, so it's in there. Alright, so do you have the link to it?
Trying to look for it now. Oh. I'm gonna assume it might be the same for this one, like as the OLED. But it's just
There it is.
yeah.
Okay, so that it used to be on here, which is starting to make me angry a little bit. So go to tools. Okay. How'd you do that? Hang on. Why is it not letting me fucking... What the hell? Okay, it's in preferences. Alright, go to File, Preferences, somewhere, Additional Board Manager URL. There it is. That's why it's showing up. Okay. So, inside here, which is Additional Board Manager's URL, you're going to type this link into that.
If I already have a link there, how should I?
You append it with a comma,
Okay.
and then that'll continue going there. What other link do you have in there?
Oh, it's for. It's like it's a mini or it's not an Arduino clone, but it's a tiny something.
Oh, it's an A-star tiny. Okay, that's cute. Yep,
What's the link?
right here. That has changed because back in my day it used to be on there. So, thank you, Paul Lulu, for making my life worse.
Should it be showing up on board manager now?
Yes.
That's good.
So once it's up there, it should be you should be able to see it in board managers as
This is the right.
Polu A-star boards. So that's what it should be showing.
So, yeah,
Darn you, Polu, for making me look stupid. Okay, let me know when we all have it integrated. Okay. It's not showing up for you?
Yeah.
First.
If you have Discord, I can just send you the link. Like,
I did have the whole thing right?
Who is the IEEE Discord? The IEEE Discord. I'm gonna post it there. Are you are you in a Discord of any student groups?
yeah, I found this out through. I think it was like after school stuff coders.
Okay, yeah, I'm on there. I'll post it to there.
Yeah, that's where I saw this, and I was like, you know what, it's good. Go
Yeah.
for it.
I am posting it to IEEE hardware. For those of you guys who are IEEE members, after school SCEMS coders, I have posted it.
I've already had it.
Yeah, okay, so, and whoever's joined the Bugs QH Discord is going to be in ground vehicles. Okay. You got it? Board. It's not showing up. That can't be good. It's right there.
Oh.
Okay. There we go. Yeah, it's showing up. It's right there. Sorry. You guys have it set up? You gotta try. Go ahead and plug in the USB and try pushing to it. So that way we know.
I did not bring a dog.
Oh, what do you need? Do you need a USB-C to A?
Yeah.
I'll just give you that for it.
Oh, you have that computer. Oh, that's amazing. I've always wanted that one. Demo program is working. Demo program is working. Okay, cool.
You won't plug it in, or should I?
I was gonna say they can share and you can have a robot, but you just gave them that instead. So. All right.
We just need to plug it in, or anything
Yep.
else?
Plug it in. Plug it in, and then you should be able to just tools. Make sure that it says Polu A-star 32U4, right? And then make sure it's the correct COM port.
Make sure it's the correct what?
COM port. So when it says port, needs this when you plug the board in, it should say COM something. It'll be a different COM number, but it'll say COM something.
Is that,
The port thing is grayed out. I can't select anything.
That means it's not plugged in.
Right.
Yeah.
Into my
Yeah.
Is
Is it grayed out on yours?
no, it has ports, but it doesn't say common there.
It doesn't?
Yeah.
Oh, because you're Mac. Yours is weird.
Yeah.
Just start testing each one until you
Yeah.
find which one is it.
Mine doesn't say that as well because I'm Linux.
There it is. Polu.
Yeah,
There's
as long as
that
it
one.
just has
Yep. There we go. You're good. Yep. So this is the demo code that's plugged in. Oh god, yours is interesting. So demo code requires that there is power. You can then press
It doesn't
B.
work on yours and mine.
Yeah, I don't know if this is from earlier. I just clear turn off.
What do you mean?
So I don't know if this was before I selected the port, but it says the current selects board needs core Arduino. That is uninstalled.
Oh, do you know what is installed?
It just says this. I don't know if it's because at that time when I plugged it in, I didn't have like the port was completely.
Oh
That's
no,
what-
that's not it. It's
And
because
also-
you're in Linux. You need to install the when you install the. You're in Arch. Oh my god, you hacker.
I need something like
You. I don't think that has.
okay.
Maybe if you're lucky.
I've already
Yep.
had it though.
should be okay. You need to install the Arduino drivers. That's what's missing.
Okay.
So there's got to be a tutorial for how to do that with Arch,
Yeah.
which I've never done before because I use Ubuntu and I'm noob and sudo apt-get works. Sudo apt usually grabs the data with you.
Current board.
Anyway, it's his fault now, so you're gonna take his robot photos and
You
program it on your
can
computer.
take them, maybe.
Alright. So where's my robot? There's my robot. So in the demo file, there's a bunch of demo codes, so you can be able to. Here's one that just moves the motors. Right. There's also one that plays. This is gonna get really annoying real quick.
Oh god.
Yeah. Again, you can create very, very interesting music. My favorite time I've ever seen someone actually use this in the field. Interesting. Why is more? Is that the music one?
No, it's just blinking the LEDs.
Oh, okay, yeah. So
do we upload the demo code?
Yep. I'll look down code so that way you can just know it works. My favorite time I've ever seen him actually use these in the real world is a friend of mine got borrowings from the library and programmed it to play I think All-Star. So that way, and then just what it would do is he also put it on the motor so that way it would find the darkest place in the room and restart it all the way 3 sides and hide. So what he would do is he would let it loose in a classroom, have it drive around the classroom, and then find a corner to hide in. So that way it would just hide there.
And it would just play All-Star?
It would just play All-Star repeatedly, and then when someone grabs it, it would just try and run away and find another place to hide. So that was my favorite code I've ever seen in the world. So this, eventually someone, he never gave me that code, so I'm really sad, but eventually I'll take the time to put it together myself and have it do the same thing. Should be crazy, but...
I was going to say, if you called out earlier when you said you can program it to play Megalovania, that's exactly what I was planning on doing.
Do it.
I will.
Yeah. Look at the demo code. The demo code will tell you how to play music. It's literally just play the chords and then time, space, and timing. So
Press B on full gas.
yeah. Okay. So
Hold on. Where's the demo code?
demo code sets it up so that way it does all the basics.
There's the B. Yeah, so that's the basics, but like when you press the button.
Oh, because your power's off. Turn your power switch on.
Oh, what is that?
It's this switch.
Okay.
Not right.
Stop.
Okay, that's fine. This one?
What? Okay, we get it. Okay.
Oh.
Is it like the sensor?
Yeah, it's the proximity sensors.
Yeah.
the heck?
So it's got proximity sensors. So that's how you know the proximity sensors right there.
And it has 2 of them.
Yeah, that's cool. Hang on.
That's cool.
Your A button's just a little bit screwed.
Okay.
Yeah, so that's it. That's what.
You see
Yep.
that? That's bad.
What's going on? You can see.
If all of the bars are just up for some reason, it's just enclosed.
Yeah. Again, so these robots are very smart. So they'll tell you all the data it has. There also should be a program for There also should be a program that tells you the IMU. Yeah. So inertial.
This touch was split.
Inertial will tell you what rotation it is. So if it's upside down, it'll be able to actually tell you, which is pretty useful.
Oh, dang.
Yeah. Okay.
Hold on. It looks like the tracks go above this, so if it's upside down, can you drive it upside down?
Yeah.
You can.
Oh.
I don't think you'd like it because
I mean, you
try
can't-
to hit the stop button with it.
That's fair.
Yeah. What's up?
No, we're just checking out the
Yeah.
inertia.
Yeah. Okay. So now that we've got that all working, we can now go back to our original code and then push our original code. By the way, I misspelled button earlier, so make sure you don't have the name button misspelled. All right, I'm gonna try and aim for 330 for us all to have some sort of code to fight with, and then we're gonna go from there. Okay. And we expect an extra token. What went wrong here?
You said to push it?
Oh, yeah. I forgot an extra. There we go.
Also, do you need to change the programmer under tools?
You shouldn't.
Okay. I was just asking because I saw you have a
You
different one than the default. Like yours says Arduino with ISP, mine says AVRISP.
Oh. That's only thing you plug on the bootloader. That doesn't matter. Yeah. I've only had you only use that if your Arduino board is bricked, and then you use that board to reformat the board from scratch. That's very rare to happen, but I've had to do it like 7 times now because I work in the makerspace and someone's like, "I shorted my Arduino. How help?" Yeah. So once we push our Robot Sumo code, we can have on it right now. Unplug. It's going to start by saying Robot Sumo, and then we're going to press A or B. So I'm going to press B. And 3, 2, 1. It's going to count off, and nothing's going to happen because we haven't written logic into it yet, right? So we're going to spend the next 10 minutes writing logic into this and hoping that we can figure out something in time. You're just getting into
That's not what I told you.
that's exactly what we chose to do because you just copy paste the.
Is it
Oh
in
wait,
loop?
is it in loop? No,
Yeah.
I
Yeah, you put it in
the
loop.
buzzer example and upload that instead.
Yeah, you put that in loop. So it's gonna keep playing that until you stop it.
I uploaded the wrong thing.
So it's literally as simple as download the buzzer example and then program to play Arduino, plug in to play Megalovania once you know how the code works. It's actually really easy. If you look at how the song is set up, just replace it's literally C8 and then C32 is middle. So it uses a keyboard keys.
Yeah.
If you play piano, you can copy paste it real quickly. Anyway, let's actually make sure we have enough robot code to fight, guys. So let's all dial back into paying attention. All right, let's get the robots now to move. So the command to set the motors is you set the speed. So the command is motors.set speeds, and then there are 2 variables, x and y, right? X and y are x comma y. So x and y are your is your power, correct? So it's a power on each motor. So your power on your x motor should be your left, R should be your right. We can actually just make it L and R. Let's make it L. Let's make it left and then right. Okay. So, do you want to do it that way or do you want to do it another way? Let's do it this way. So, the maximum power you can pull out of your left and right motor is 400. But what's really interesting is I can also pull minus 400. So you can reverse just as fast as you want to go forward, right? This command sets it to just whenever you push the button, it'll go forward for a short period of time and then stop. So we want to make sure that it continues to go forward. We need to make sure that we set a delay time. So let's set it for 300 milliseconds. So this command goes forward for 400 milliseconds and then waits for 300 milliseconds before it executes the next command. Finally, at the next command, what do you want to do at the very end? We don't want to drive off the board, so we want it to brake. For motors, set speeds, 0.0, no matter how much power you pull out of it, sets it to stop moving. So that is your shutdown. Okay? And that is your basic ramming code right here. Maximum power forward, delay time for 30 seconds, stop, and then you're done. Right? So we're going to call this ramming code. And I'm going to pretend I didn't miss my own brackets. So now, if we push this to a robot, webcam's not working. Great. What's up, bro? Hey, Kurt. Old buddy of mine. Okay. So now, if we push it to a robot, what it'll do exactly is just that. I think that's code A. That's in code A. Right? So that's traveling at maximum speed for 200 milliseconds. Let's say we want to push another robot out of the ring, and we assume the other robot's not going to go too far. How much time do you think, if this is 200 milliseconds, how much time do you think we need to go before to push a robot out of the ring?
900?
600, 700.
6? A little bit more than 600.
So let's try that. Let's try. I like 700 better. So let's try 700. Oh, that was a good estimate. Oh right, the robot's not plugged in. Yep. Yep. Did you change the number?
No, it's at 300.
Yeah.
Yeah, you can make it sure.
Yep. So that's still a little bit too far because it's kind of getting the edge of the ring. Yep. But yeah, that's your plan. Okay.
Did we? Yeah, 650, 650, 650.
Let's aim for 600.
I didn't press the button.
Yeah. Yeah.
Yes.
You finally compiled? Hey.
I was
Nice.
having debugging issues.
Your battery's not, your power's not on for your robot. So, like here's the switch, and that turns on the battery to your power to your motors. So you can push A again to restart.
Yeah.
That was like, okay. All right. So let's just see what happens.
Which one's A?
A is that middle one, right? So
This
ready?
middle one?
So left one.
Left one.
Ready? 3, 2, 1.
Fuck, I didn't press it.
Yeah, so that's what happens when you don't press it. Try again. 3, 2, 1. Right. So as you can see, when you have two aiming robots, nothing happens. You just push each other and then you hope. Right?
Have you ever played Rocket League?
Yes. That's exactly what, you know, the robot was this workshop was actually initially supposed to be robot soccer, where we use Zumos to push soccer ball.
Really?
Um,
It's real life thing.
The only problem is that I couldn't write enough code in time to get you guys to do that. It would have taken it would have taken 3 workshops to do that workshop. So, yeah. Right. So, if you know you're going to be ramming straight into an opponent, it's probably better to run the motor for a little bit longer or to code proximity sensor into it so that we can do it that way. But let's say that you know the opponent's going to ram into you and that's the only function code that they have. What option do you have next? Well, you can do a dodge function, right? So, if we had a robot lined up here, how would we get it to dodge? What options do we have for movement?
We back it up at an angle.
Yeah. So you can back up as an angle. So that's probably the best way to start. So how are we back up as an angle?
Set speed,
One of them too.
Yeah.
and then you set one and faster than the other.
Yep. And make sure that they're negatives, that way it's actually backing up and going forward. Right? So let's go ahead and copy paste our code in. And this time let's make it minus 400 and let's make it minus 150 is what I had. I think. I should think my demo code was actually minus 200. It's plus 200. Isn't it nice that it gives a little beep whenever you finish programming it, so that way it knows, I know it's done its thing? That was a problem because it went out of the wing. You saw that?
Well, it wasn't in the center.
Is my USB just like really bad?
Do you need a different USB?
Yeah, it is out of the ring.
I'll give you this USB.
All the way.
Oh, your power's not on. The motor power's not on. So see the switch next on the left? No, all the way down. Right there. Yeah, the switch. Yep. Now you have enough battery to run everything. And OBS is crashed. Wonderful. Right? So that was a lot of power. You saw that?
Oh.
Well, OBS is crashed, so the stream is dead. The numbers that I found that worked for just backing up and turning to the left are minus 200, minus 50. So
I guess I do need a new one.
it wants to run. And sorry, Twitch, you are going to die today.
No, not Twitch.tv.
Why can't I disable